In Chapter 2, we took a look at how to construct visual displays of our data through histograms, bar charts, pie charts, stem and leaf plots, and other various ways of visually representing our data, which is really advantageous because often a visual representation is what helps a person understand really efficiently how the data is behaving. But we also want to make sure that we're being rigorous mathematically in that we understand from not just a visual standpoint, but from a calculation standpoint how our data is behaving. And there's two primary ways that we approach how to mathematically or numerically describe our data. And the first of those two we're going to take a look at in section 3.1. In section 3.1, we're taking a look at what are called measures of central tendency. That's just a fancy way of saying, where's the middle of my data? If I've got my big list of data, how can I describe the middle of it? Now, when I say that, probably the thing you're thinking of the most is, oh, that's just an average, right? Well, interestingly enough, there are multiple ways to calculate what we have come to call an average. Okay, we're going to call them measures of central tendency, and we're going to take a look at 4 different ways to represent the center of your data set. But before we do that, we need to make sure we understand something that we've taken a look at already, but we just want to reinforce it. Right? The difference between populations and samples. Interestingly enough, when we use the word statistic, we are actually referring to a measurement obtained from data values that came from not a full population, but a subset of the population, which we call sample. So whenever we say a statistic, we're actually talking about a small sample of our full population of interest. However, we're going to use the word parameter when we're talking about something describing the entire population. Now, you can probably guess why this is going to be important as we progress through this course, because often it's impossible to actually collect all the data to calculate a parameter. As if our population is the entire state of Oregon, that's several million people. That's going to be pretty much impossible, right? But can I gather information about a smaller group of Oregonians? Yeah, I can. So the question is, can I use a statistic to estimate a parameter? In other words, can I use my sample to estimate my population? And what we're going to find out is yes, with some caveats there. But right now, all we need to remember is when we hear the word statistic, we're talking about a measurement obtained by using data values from a sample. Whenever we use the parameter, same thing, measurement obtained, but instead of using data values from a sample, it's data values from the entire population that we're interested in. So let's move on. First measure of central tendency. This is the one that most people are familiar with. It's the mean. This is the one that we often describe as an average. Right? The mean is the sum of all the values divided by the total number of values. Right? We've been doing this since grade school, calculating an average. We're going to be a little more precise in that it's going to be called a mean. Right? Now, again, all we're going to do is, if we have a set of values that we want to find the mean for, we add up all those values. That's what's represented here by x1 plus x2 plus x3 all the way to x sub n. That's just a fancy way of saying we're going to add up all the values, right? And then we're going to divide by n. N is the variable we use for the number of data values in our data set. Okay? Again, something we've been doing for years as studying mathematics, right? But here's the difference. If I'm calculating a sample mean, in other words, a statistic, here is the symbol right here that I use for mean. we say that x bar. Now, we could say that our variable that represents all of our data is y. All I would do is go y bar, and that would mean the average of y. Okay? I could use any letter there. The letter isn't what matters. It's the bar above it that matters. That means you're calculating a mean. Right? But notice if we're calculating the mean of the entire population, we use this Greek letter that's pronounced mu. So you can see that the formula here and here look identical. The only difference is when we're dealing with a sample, we use x bar. When we're dealing with a whole population, we use mu. And then also you'll notice that when we are dealing with a population, look at this, the n is capitalized. When n is capitalized, that means that's the total number of people in our entire population. When it's a lowercase n, that means we're using a subset of our population of size n, 10 or 30 or 50 data values from our population, a sample of our population. So let's actually calculate a mean now. We've got our example here, avian flu cases. The number of confirmed flu cases for a 9-year period is shown. Find the mean. Okay, so in 1 year, there was 4 cases. In another year, there was 46 cases, and the list goes on. Can I find the mean? Well, yes. What do? We take all those values and we add them together. If I were to quickly add those together, I would end up with a value of 578. 578. Right? Okay, so I added them all together, but what do I now have to do? I have to divide by how many data values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to divide that by 9, and it's only 9 years out of several, a much more broad range of years that the avian flu cases have been tracked. And so we know that this is just a sample of the full set of data. So instead of mu, which is for a full population, I'm going to use x bar. X bar equals 578 divided by 9, which equals 64.2 if we worked that out. Great. Wonderful. So we were able to calculate the mean, which is one way to describe the center of our data set. Great. Now, one thing you'll remember, though, is sometimes we're not given all of the values with a data set that we're working with, right? Let's take a look at another example to calculate the mean. It says this, the frequency distribution, I don't have all my actual data values. The frequency distribution shows the salaries in millions for a specific year of the top 25 CEOs in the United States. Find the mean. Now here's the problem. I know that 13 of the top 25 CEOs earn somewhere between $15.5 and $20.5 million a year. But I don't actually know the data values. Furthermore, I've got 6 of those CEOs who earn somewhere between $20.5 and $25.5 million a year. Right? But again, I don't know the actual values. So the question is, how do we calculate that? Well, it's actually a pretty simple way to do it. The way we do it is we essentially estimate. Right? So here's what we're going to do. First, we are going to find the midpoints of each of our classes. What is the midpoint of 15.5 and 20.5? Okay? Well, the midpoint is 18. One way to quickly do that is to do 15.5 plus 20.5. Right? That's a 6 there and a 3 there. So 36, and then divide by 2. Well, 36 divided by 2 is 18. There's my 18. Right? Okay, so 18 is the midpoint there. If I were to calculate the midpoints, the next one would be 23, and then 28, and then 33, and then 38. So those are the midpoints of my classes over here. Here's then what we're going to do. We're going to say, well, 13 of the CEOs had on average a salary of $18 million a year. So all we're going to do is multiply 13 times 18, and that gives me 234. So I know that these 13 CEOs have a total salary combined of 234. Now I'm just going to do that with the remaining rows. 6 times 23 is 138. 4 times 28 is 112. 1 times 33 is 33, and 1 times 38 is 38. So what I can now do is, if I add all of these up, I'd end up with 555, and that represents the total salary of all top 525 CEOs, that all combined, that's what they make. How can I find my average? I take that total value and I divide by the number of CEOs, 25. So I'm going to say X bar is equal to 555 divided by 25, which equals $22.2 million. So, according to my frequency distribution, the top 25 CEOs, top 25 paid CEOs in the United States for a given year, on average, make $22.2 million. You'll notice that 22.2 million is much closer to the lower class than it is to the highest class. Well, why? Because most CEOs make closer to that lower class than that highest class. Great. There's one other scenario in which we have to discuss how to calculate a mean. So we're still talking means here, okay? But it's this concept of a weighted mean. Okay? Now, we've got this formula right here. It says, find the weighted mean of a variable x by multiplying each value by its corresponding weight and dividing the sum of the products by the sum of the weights. So x bar equals W1, x1 plus W2, x2 plus ... Big nasty formula. What does all of that mean? Well, let's take a look at an example to figure out what that means. So it says this: a student received an A in English, Composition 1, which was a 3-credit class. They received a C in Introduction to Psychology, which is another 3-credit class. They received a B in Biology, but that's a 4-credit class. They received a D in Physical Education, which is only a 2-credit class. Now, the way the grade point average system works is that an A gives you 4 points, a B gives you 3 points, a C gives you 2 points, and a D gives you 1 point. You get nothing for an F, right? Here's what it says: find the student's grade point average. Okay, so here's the scenario. We've got it organized here in our table where English composition was 3 credits, and they earned an A, which gave them 4 points. Now, here's the interesting scenario. Okay, this English composition class, it actually counts towards more of your GPA than physical education. Why? Because it was a 3-credit class. Physical education was only a 2-credit class. But then you have biology here, which was a 4-credit class. So biology actually has the biggest impact on your GPA. Right? The question is, how do we work out a scenario where we make sure that biology has the biggest impact, English composition and Introduction to Psychology have the next largest impact on your GPA, and then physical education has the smallest impact on your GPA, which in this case is a good thing because you got a D in physical education, right? Here's how we do that. The formula up there where it said that X bar is equal to the sum, that was a terrible sum sign, the sum of WX all over the sum, wow, I'm really messing those up, of the sum of W Here's what that means. What we're going to do is we are going to take our W column and our X column, and we're going to multiply the W's times the X's. Look at what that does. Okay? It says this 4 for earning an A is weighted at a 3. So 3 times 4 equals 12. This C that I earned in psychology, I get 2 points there, and it's weighted as 3 credits. So that's going to be 3 times 2, which equals 6. Okay? But now we're on to biology, right? And in biology, it counts for 4 credits, and I earned 3 points for a B. So we're actually going to do 4 times 3, which equals 12. Notice this, that I got just as much points for biology as I did for English composition, right? But why? Because biology counts for more, but I only got a B, right? But I got an A in English composition, which helped me quite a bit. Okay? And then lastly, the weight of 2 times I earned 1 point for a D in physical education gives me a 2 here. Wonderful. So what we're going to do now is, now that I've multiplied all my W's times my X's, I'm going to add all those up. That's what this symbol right here means, the sum. So 12 plus 6 is 18, plus another 12 is 30, plus 2 is 32. So my numerator here is 32. But then it says I'm going to divide by the sum of all of my weights, the W. Well, 3 plus 3 is 6, plus 4 is 10, plus 2 is 12. So we're going to divide this by a 12. If I do 32 divided by 12, that means I earned a GPA of 2.7. 32 divided by 12 is 2.7. Great. So if you have a scenario where not all data values are equal to each other, meaning one data should count more than another depending on some weighted system here, right? You do your weight times your actual data value, add all those up together, and then divide by the sum of all the weighted values. Great. So again, we calculated a mean. The mean is one of our 4 ways of describing the center of a set of data. Great. Well, let's take a look at our next measurement of center. The median. The median is the midpoint of the data array. The symbol for median is MD. MD stands for median. Okay. Well, how do we calculate median? It's the midpoint. The data shows the number of tablet sales in millions of units for a 5-year period. Find the median. Here's the process to find the median. I am going to rewrite my data here from smallest to largest. So that's 17.6, and then I think it's 69.8, and then it's 108.2, and then 159.8, and then 222.6. Then simply what I'm going to do is I'm going to find the middle value. Well, if I just crossed off one off on each side and then the next one off, what's my middle number? My median, MD, is equal to 108.2. So with calculating the median, order actually matters. It matters so that you can identify the midpoint. There's actually no calculations involved at all. You're simply lining up from smallest to greatest and finding that middle number. Okay. Well, let's take a look at another example. You'll see why we're going to take a look at another example when we get into it, because there's a unique scenario that sometimes pops up with finding the median. The number of tornadoes that have occurred in the United States over an 8-year period is as follows. Find the median. Okay, so we know that we have to list these from smallest to greatest. So 656 right there, and then 684 right there. Then it looks like we have a 764. And oh, nope, I had a 702 first, didn't I? 702 and then 764. And then I've got an 856. And let's see, I've had a 1132, and then a 1133, and then a 1303. Great. So again, let's find the middle. Cross those off, cross those off. Oh, do you see the scenario that we have ourselves in here? Which one of those is the middle? Well, the answer is both of them are the middle. Okay? But if both of them are the middle, I'm sorry about that. If both of them are the middle, how do we actually state what the median is? Well, what we simply do is we find an average. We find an average of those two middle values. So 764 plus 856, and then we're going to divide that by 2. What we get is 1,620 divided by 2, which is 810. So the median for that data set, 810. Great. It's halfway between these two middle numbers. So that's our second measurement for calculating the center of our data set. We've got 2 more. This next one's an interesting one, not often used, but it has its place in certain contexts. The mode. So one way to describe where the center of your data is simply to just ask the question, which value occurs the most? Which one occurs the most? So let's look at our first data set here. The data show the number of public libraries in a sample of 8 states. Find the mode. Okay, well, do I see any values that occur multiple times? Look at that. I have 2 values of 77. So we would say that the mode of that data set is 77. Great. It's that simple. Mode is which one occurs the most. Okay? Let's look at another example for mode, because sometimes it's not that clean. Okay? The data shows the number of licensed nuclear reactors in the United States for a recent 15-year period. Find the mode. Wow, I'm seeing a lot of 104s. In fact, I'm seeing 5 of them right there. So does that mean my mode is equal to 104? Well, before we jump the gun, take a look at this. 109, 109, 109, 109, 109. Ah, I have another value that occurs the same amount as the 104. Both of them occur the most. We call this bimodal. Obviously, bi meaning 2. We have 2 modes. We have 2 values that occur the most. And interestingly enough, we could actually run into a scenario where we have even more than 2 values that occur the most. We call those multimodal. Great. Okay. Now, sometimes we have a scenario again where maybe we don't know all of our data sets, but we have a frequency distribution. This right here is back to that example of the CEO salaries in the United States. Well, in that case, since I don't know my actual data values, I can't calculate the mode. But what I can do is this. Which of my classes has the largest frequency? Well, it's this class right here, $15.5 to $20.5 million a year. It has a frequency of 13. So we would say, look at that, we call that the modal class. It's the class in our frequency distribution that occurs the most. Wonderful. Well, we could also do that with categorical data right here. Right? Which one of these, the data shows the number of gallons of various non-alcoholic drinks Americans consume in a year. Find the mode. Well, which one of these is the modal category? Well, it's the one that has the largest frequency. And looks like for us, it's soft drinks. So we would say this is the modal class or the modal category, because we're dealing with categorical data. Wonderful. The last way to describe the center of a data set is this concept of a mid-range. It's important to know, but it's actually not used a tremendous amount. But we're going to take a look at it nonetheless because we do find that it comes up every once in a while. The mid-range is defined as the sum of the lowest and highest values in the data set divided by 2, when we use MR to represent mid-range. Okay, so following that, let's do that with this example right here. The number of bank failures for a recent 5-year period is shown. Find the mid-range. So what does it say mid-range is? We take and we do the lowest value. Let's see, in here my lowest value is a 3, and we add it to our largest value. That's my 157, and we divide that by 2. So that's going to be a 160, that's 3 plus 157, divided by 2, which equals 80. So the mid-range says this: here's my highest, here's my lowest. What is smack dab right in the middle? What's halfway between my largest and smallest values? So measurements of central tendency describe the center of our data: the mean, the median, the mode, and the mid-range. To wrap things up, I want to show you something really quick. In that all of these can be really quickly calculated, using a calculator. Pretty simple, pretty straightforward. But sometimes we're given, in our homework sets, we're given the actual data values, and there's quite a few, 20, 30, 40 data values, and it's a little bit cumbersome to try to find the mean and the median and the mode and the mid-range when we're taking a look at that data set. But as you know, often you can take and or export that data set into Excel. So let's go ahead and take a look at a data set in Excel really quick. Let's hide this and open up Excel. Okay. There we go. And let's go ahead and take a look at how we can actually use Excel to find these values. Let's take a look at this. Mean. Here's my data. The data show the heights and feet of 14 roller coasters. Okay. So here's the heights of 14 different roller coasters. Well, how can I calculate my mean? So I'm just going to highlight a cell where I want to calculate my mean. I'm going to hit my equal button. And then with my equal button hit, I am going to type in average, A-V-E-R-A-G-E, okay? And then I'm going to do open parenthesis. Then I'm going to come over here with my cursor, and I'm going to click and hold down on that top cell and drag all the way down and then let go. So that's going to highlight all of those values, and then I'm going to close my parenthesis. So I'm instructing Excel in that cell right there to say I want that cell to equal the average. So in Excel, average means mean. And I'm going to hit enter. And there we go. The average height of those 14 roller coasters is 104.1-ish feet. Great. Well, what about median? Again, I'm going to hit my equal sign, and I'm going to start typing in median. And take a look at that, M-E-D-I-A-N. There's a median formula in there. Open parenthesis again. Same thing, click and hold, drag down to select all my data values. Close parenthesis. I'm going to hit enter. Perfect. Okay, it says that if I were to line that up from smallest to greatest, guess what the middle number would be? It would be this value right here, the 102. What about mode? Okay, well, again, I'm going to hit my equal sign, and I'm going to start typing in M-O-D-E. But here's what I want to do to make sure that I actually get all my potential values. See this one that says mode dot M-U-L-T, mode.mult, that's multimodal. I'm going to open my parenthesis. I'm going to highlight all of my data values, and I'm going to close parenthesis and hit enter. And look at that. What it'll do is it'll actually create an array, a vertical array, and it's going to list for you all of the values that occur the most. 95 occurs once twice. There's the other one down there. 50, it's right here and here. Oh, that also occurs twice. Same thing with 102. And lastly, same thing with 160. All of those occur twice. So this is multimodal. Lastly, we have mid-range. There's no formula built into Excel for calculating mid-range, but we can actually build the formula. All I'm going to do is hit my equal sign. I'm going to open my parenthesis, and well, I know that I want to do my maximum value. Well, if I look through this, my maximum value here is 160. And I'm going to add that to my lowest value. Looking through this, my lowest value is 50. I'm going to close parenthesis, but then what were we supposed to do? Our max plus our minimum, and then I'm going to hit my /, which is my division symbol in Excel, and then 2. So we're dividing that by 2. Hit enter, and it says my mid-range, halfway between my largest and smallest value, is 105. Really interestingly enough, though, if I have a huge data set, and it's like, man, how in the world do I find my minimum value? Well, there's a formula for that, interestingly enough. If I hit equal, and I type in min, open parenthesis, again, click hold to highlight all my data, close parenthesis and hit enter, it's going to go find that the minimum value is 50. What about my maximum? Okay, well, equals max, open parenthesis, highlight all of my data again, close my parenthesis, and hit enter. And look, it found the 160, my maximum value. So Excel, really powerful tool, right? When you can import your data from the homework problems or exam problems into Excel, Excel very powerful at being able to help you calculate the values for your measures of central tendency.